All right, you found Pre-Algebra lesson 4.1, and we're ready to start chapter 4. And we're going to start off with prime and composite numbers. So talking about prime numbers and composite numbers. Okay? All right, so a couple things right off the bat. First off, let's talk about a multiple. A multiple. What is a multiple? A multiple is um, the multiple of an integer is the product. That means multiplication, right? Is the product of that integer and any natural number. And here's a reminder of the natural numbers, right? 1, 2, 3, and up. All right, so what is the multiple of an integer? It's the product of that integer and any natural number. So let's go through and I'll show you exactly what we mean here. Pretty simplistic. So A says list the first 5 multiples of 2. Okay, so just take the 2 and multiply it times the first natural number, which would be 1. And we all know 2 times 1 is 2. So 2 is the first multiple of 2. Then let's multiply by 2 and we get 4. 4 is the second multiple. Multiply by 3 and we get 6. And you see now the pattern here, pretty simplistic, all the way up through 10, right? So what are the first 5 multiples of 2? Well, multiply the 2 times a 1, and then a 2, a 3, a 4, and a 5. And that's how you'd get the first 5 multiples of any number. Multiply the first number, multiply it first by 1, then by 2, then by 3, then by 4, then by 5. So here we have a negative 7, and it asks for the first 5 multiples of negative 7. So again, this is pretty simplistic. You're going to multiply by 1, get the first multiple by 2, get the second by 3, get the third by 4, get the fourth, and by 5, and get the fifth. All right? The first 5 multiples of negative 7. So when it asks for multiples, you are multiplying by the natural numbers. Okay, so let's take a look at the aspect of the word factor. Use my green here. Factor. What's factor of a number? Factor of a number are 2 or more integers where their product is the number. 2 or more integers where the product is the number. For example, let's suppose you had the number 10. The factors of 10 would be 2 and 5, right? 2 or more integers where their product is the number. So a 10 has factors of 2 and 5. Now, technically, you can say factors of 1 and 10, but 1's kind of boring. Okay? All right, so here's a question. Is 3 a factor of 108? Is 3 a factor of 108? Well, you can divide 108 by 3 to see if there's no remainder. So what are we saying when we say there's no remainder? We're really saying that that 3 evenly divides into 108, no remainder. It divides into it evenly. So we'll just do the little division here. All right, can we still do long division? 3 goes into 10 3 times, 9, subtract to get a 1, bring down the 8s, and 3 goes in 18, 6 times. And what is our remainder? There is no remainder, so yes, indeed, 3 is a factor. Now, don't miss this fact. This is what we just found. We found that 3 times 36 will equal that 108. And by the way, we see that there are other factors of 108 as well because of that 36. All right, so if you divide the number into it, and if it divides evenly, there's no remainder, then yes, it is a factor. So 3 is a factor of 108. You might be saying, hey, wait. I know some divisibility rules. Yeah, I know. We're getting to those in a minute. All right, hang on there. We're getting to those. All right, so let's do B here. Is 7 a factor of 750? Hey, just do your long division. Just do your long division. A 1, bring down the 5, a 0, bring down the L. 7 times 7 is 49, remainder of 1, and that would be a no, right? No, 7 is not a factor. of 750, because I got to tell you, 7 times 107 does not give you 750. You will fall short. All right, so what is the test on these? Simply divide the 7 into the 750, the 3 into the 108. On your homework, there'll come a section where they'll want you to determine whether or not something is a factor. I want you to show the division of those, okay? And I'll explain that tomorrow in class. All right, divisibility rules. Let's go through the divisibility rules. Hopefully you know these already, and this is a quick review, and this should be a quick lesson today, all right? I hope. All right, divisibility rules. Let's go through two. Do you know the divisibility for rule for two? Some would say any even number. So the divisibility rule for twos is any even number. If it's an even number, it's divisible by two. And let me just help you out. What's an even number? Well, of course, the number ends in 0, 2, 4, 6, or 8. Who do we appreciate? Yes. All right. Hopefully in your living room right now, you're saying, Mr. Scarfy. Yes. All right. Divisibility rule of 5. Pretty simplistic. The number will end in, so number ends in, and you know it, right? What does it end in? 0 or 5, right? Any number that ends in 0 or 5 is divisible by 5, and divisibility by 10, of course, any number that ends in 0, right? Pretty simplistic ones. Is it divisible by 2, 5, or 10? Those you should be able to recognize at just a quick glance. Should be able to recognize at a quick glance. All right, let's get to a few that you'll have to remember. How about 4? What's the divisibility rule for 4? Do you remember it? Well, I gave you most of it here. Divisibility by 4 is the fact of, are the last two digits are evenly divisible by 4. By the way, there is one exception, or it ends in 0, 0, right? Which is technically 100, and that is divisible by 4. So divisibility rules. Okay, so here's an example. We've got the number 7,172. Is that divisible by 4? Well, pretty simplistic. We're going to take the 72 and we're going to simply divide the 4. Excuse me, a lot of sound there, I know. We're going to divide the 4 into the 72. 4 goes into 7 one time, bring down the 2. 4 goes into 32, 8, no remainder, right? So that would be a yes. And again, you're showing the check of the divisibility rule. Whenever you have to show whether a number is divisible by 4, please show me the dividing of the 4 into the last two digits. 1, it tells me that yes, indeed, you know the divisibility rule, and 2, it helps you to remember that divisibility rule. So again, whenever I ask for a 4, you need to show it. Do you need to show a 2, a 5, or a 10? No, those you can tell just by looking at the number. You don't need to show me anything to state whether it's divisible by 2, 5, or 10. But if it's divisible by 4, I want you to show me the division. And that's simply what we've just done right here, right? Come on, pens, where are you? Oh, man, my board is acting funny today. All right, so again, this is what I want you to show me, right? If indeed you're going to prove divisibility by 4. Okay, let's go on. About divisibility by 3? Do you know the divisibility by 3 rule, or do you remember it? Well, divisibility by 3 is the sum of the digits are evenly divisible by 3. The sum of the digits are evenly divisible by 3. So again, I'll want you to show me this rule. So I want to divide 3 into, let's see, I have a 1, right? I'm looking at the number right over here, right? So I have a 1, and 3 is 4, and 2 is 6. So does 3 evenly divide into 6? Oh, yeah. 3 evenly divides into 6, and so that would be a yes. And again, I'm looking for you to show me I'm looking for you to show me this division, right? I want you to show me the division of dividing the 3 into the sum of the digits. Dividing the 3 into the sum of the digits. Okay? How about 9? Do you remember the divisibility rule for 9? Well, it's very similar to 3. Divisibility rule for 9 is very similar to 3. And so it's the sum of the digits are evenly divisible by 9. And again, I want you to show me the check. So you're going to take the 9, you're going to divide it into, here's our number, right? 840. So you have an 8 and a 4, that's a 12. Does 9 evenly go into 12? You know, you don't even have to go any farther than that on a number like this. The answer is no, but just show me that before you state your no. This way I know that you understand the divisibility rule. You didn't punch it on a calculator. You didn't get it off the internet. You know what you're doing. Again, I'm trying to get you to hopefully remember it. Okay, divisibility rules. Pretty simplistic. So again, 2, 5, 10. Not a problem. You can do them without showing any kind of work. 4, 3, and 9, please show me the work. Anything else, you're going to have to divide it in. Is there a divisibility rule for 7? No. You're going to have to divide the number by 7 and see if it divides evenly. Is there a divisibility rule for 11? No. You have to divide the number by 11 and show that it divides in evenly. 13? No. Divide it by 13. You follow? Okay. Very good. Let's talk about prime numbers. Prime numbers. A prime number is a natural number greater than 1. All right, so listen, is 1 considered a prime number? The answer is no. It's a natural number greater than 1 that has exactly 2 positive factors, 1 and itself. In other words, it has no other factors but 1. All right, that's it. So any number greater than 1, any natural number greater than 1 that has the only factor of it is 1 in itself. So I've listed the first bunch here. Write the number 2. So 2 has no factors except for 1. Next prime number is 3. 3 has no factors except for 3. 5 is the next one. Oh, I skipped 4, didn't I? Why did I skip 4? Because 4 is a 2 times 2. Ah, see how you have factors? I skipped 6, right? Why did I skip 6? Right, 6 right in here? Well, because 6 is a 2 times 3. So 7 is the next prime number. 8's not prime. 9's not prime. 10 is not prime. Oh, 11 is prime. 12 is not prime. 13 is prime. Do you know the next prime number? It's not 14. It's not 15. It's not 16. Oh, it is 17, right? It's the next prime number. What about the next one? What are you thinking? Got anything? Hopefully you're thinking 19. 19. How about the next one? Can you get to the next one? What are you thinking? How about 23? All right. Next one, and again, this is what you're doing. You're just thinking through the next numbers. 22, 2 times 11. I'm sorry, 24, right? Oh, 2 times 12, et cetera, et cetera. 25, 5 times 5. 26, 2 times 13. 27, 3 times 9. 28, 4 times 7. 29, 29, 29. Yeah, that's prime. All right. 30, no, 3 times 10. 31. It's prime, right? And then next would be 37, 41, 43, 47, dot, dot, dot. They go on forever and ever. And we'll talk more about that when we get to factoring and figuring out whether we're to prime factors or not. Okay? So prime numbers, and you should know what they are. All right, leaves us with the last thing here today. A number that is not a prime number is a, do you remember? Well, it was the title of the lesson. It's a composite number. A composite means it's made up of 2 or more things. So a composite number made up of 2 or more factors. So any number that is not prime is composite. All right. Now again, you don't consider 1. We go above 1. All right. Is 6 a composite number? Sure. It's a 2 times 3. Is 4 a composite number? Yes. I don't know, 22, 2 times 11, 100, a million. Any number that is not prime is composite. All right, let me do a quick recap here. Um, what is a multiple of an integer? It's the product of that integer and any natural number. So again, when they ask you for the multiples, you're going to multiply. The first multiple is multiplied by 1, second by 2, third by 3, etc. And I showed you there the first 5 multiples of the number 2, and then the first 5 multiples of the number 7. What about factors? A factor of a number or 2 or more integers where the product of the number, um, excuse me, a factor of a number or 2 or more integers where their product is the number. Again, multiplying 2 things together or more to equal that number. If you're asked, is a number a factor of another number, simply divide it into that number and see if it divides in evenly, no remainder. All right, we did that with 3 in the 108, and that was a yes, and 7 in the 750, and that was a no. All right, then we talked about divisibility rules. Remember, 2, 5, and 10. Never have to show me those. You can just look at the number and determine. But if you're going to prove something divisible by 4, I need you to show me, right, the dividing of the 4 into the last 2 numbers. 3 and 9, if you're going to state whether or not a number is divisible by 3 or 9, you're going to have to show me dividing the 3 or the 9 into the sum of the digits of that number and show that it divides in evenly or not. Prime number, it's a natural number greater than 1 that has exactly 2 positive factors, 1 in itself, when we listed the first bunch there. Remember, any number that is not prime is composite. All right, that's the lesson for today. And you guys have a 3-day weekend, so that's awesome. Hope you enjoy it. We'll be at the couples conference, and we'll see you in school on Monday. Remember, don't worry about the homework. You'll be taking care of that in class on Monday. All right, have a great night.